We now talk about refraction through a prism. So we are going to talk about refraction through a prism. So let us see at the figure now. So say you have a prism and the angle of the prism is A. So you have an angle A here. So this is the incident light. So the light is coming in this direction. So this is the normal. It gets refracted here. The first angle of refraction is R1. Now it gets incident on the second surface. So you could say this R2 as I2, that is the second incidence, but we will just put it as R2. And then this light strikes the second surface. So this is the second angle of incidence. And then this light comes out here. So this E is the angle of refraction when the light comes out in the air. But we are putting here the second angle of incidence as R2 and this as E. Now quick things. So if this angle is R1, so if there was no glass, the light would have gone in this direction. So you can see this angle and this angle is I. These are opposite angles. In mathematics you would have seen that if these are two lines, the angle here is equal to angle here and angle here is equal to angle here. So this angle is I, so therefore this angle has to be I minus R1, so that this total angle is again I. Since this angle is E, this angle has to be E minus R2, so that E minus R2 plus R2 becomes E, so that this also becomes E. Now this delta, which is this exterior angle, so this delta is the angle of deviation. So notice that delta is, so this is the angle of incidence, this red line. So this is what the original ray of light would have gone to if there was no prism, and this is the final. So because of prism, the light goes in this direction. So delta is the change in the direction of the light. So originally the light would have gone in this direction, but because of the prism, the light is going in this direction. So it enters here and it exits here. So delta is the angle of deviation in the direction of the light. Now this delta is an exterior angle. So you can see this delta is equal to sum of this I minus R1 plus E minus R2. So we have written this here. Delta is equal to I minus R1 plus E minus R2. Now you focus on the quadrilateral. So this is the quadrilateral you need to focus on. So I'm marking the 4 vertices of the quadrilateral: 1, 2, 3 and 4. So first notice that in this quadrilateral there are two angles which are 90 degrees. So one angle is 90 degrees, which is right here because of the normal, because normal makes an angle of 90 degrees, and the second 90 degree angle is here. So since sum of angles of a quadrilateral is 360 degrees and these two angles are already summing to 180 degrees because both of them are 90 degrees, you get A plus N as 180 degrees. Now in this small triangle, so now we focus on this triangle. I'm marking its 3 vertices in green. You have R1 plus R2 plus N is 180 degrees. So you have R1 plus R2 plus N is 180 degrees. So this is equation 1, this is equation 2. So from 1 you subtract 2 and this will give you A is equal to R1 plus R2, and this we will use later. So now if you conduct an experiment, you keep changing the angle of incidence and you keep measuring this E, you will find that the angle of deviation is minimum when I is equal to E. Now when I is equal to E, so if these two angles are equal, that means R1 will be equal to R2. Because if I is equal to E, this ray would be parallel to the floor and this will become an isosceles triangle. So this triangle will become isosceles if I is equal to E, because then I minus R1 and E minus R2 will also become equal. since this will be a parallel line. So R1 will become equal to R2, and you say R1 is equal to R2 is equal to R. You set R1 equal to R2 equal to R, and since the deviation is minimum, you set delta is equal to dm. So this implies, first thing here is that now A becomes, so this you put as R, this you put as R, becomes 2R. So you get R is equal to A by 2. Yeah, and here since I is equal to E, so you put this as 2I minus A. This is equal to delta. So delta is equal to 2I minus A, but delta you're setting as dm. So dm is equal to 2I minus A. So you rearrange this and you get the angle of incidence as A plus dm by 2. Now we just apply the Snell law. So angle of incidence is here. So sine I by sine R is equal to n21. So that is nothing but n2 over n1. So sine I is sine of A plus dm by 2. So this is what we are writing for R, and R is equal to A by 2. So this is what we are writing for R, and this is we are writing for I. Now we talk about dispersion by a prism. So when a narrow beam of white light falls on a prism, so you have a beam of white light, it falls on the prism, it splits into its component colors: violet, indigo, blue, green, yellow and orange. This you call as Vibgyor. So this phenomenon is called dispersion. So you have white light falling on the prism and it splits into these colors. So if you keep a prism in a dark room and the light falls here, so you have only one beam of light falling on the prism. So this is the component colors you will see.